Hi. I'm gonna be doing the 2021 AMC10B problem 20. So the problem asks, the figure is constructed from 11 line segments, each of which has length 2. The area of pentagon ABCD can be written as the square root of m plus the square root of n, where m and n are positive integers. What is the value of m plus n? Is it A, 20, B, 21, C, 22, D, 23, or E, 24? All right. So the first thing that I'm going to do is just construct this pentagon really quickly. So just label it A, B, C, D, and E. All right. So the next thing we can do is just divide this into 3 sections. And the construction for this problem is pretty clear. The motivation is that we're just going to add 1, 2, and 3 together to get something written in the form the square root of n plus the square root of m. And then we'll just add m and n together to finish solving the problem. Okay, so let's begin solving with all that background information. Okay, so the first thing we notice is that when we draw this line segment, since every line segment has the same length, this angle right here should be equal to 120 degrees. Basically, the reason for that is because this angle right here is equal to 60 degrees, again, and it perfectly divides angle B. So it would just be 60 degrees times 2, which is 120 degrees, right? Okay, so now we can try to find the area of this. So we know the area for this triangle would be AB times sine of theta over 2. So plugging this in, we get that this is 2 times 2 times sine of 120 over 2. So these two 2's cancel out. And so we're left with 2 times sine of 120. And sine of 120 is the same thing as sine of 60. So we get that this is 2 times the square root of 3 over 2, which is equal to root 3, right? But there's 2 of these sections. So we can rewrite this as 2 times the square root of 3, right? To find the area of both of these. Okay. So we have now essentially found the area of both of these triangles, 1 and 3. So we're just going to move on to 2. I'm just writing the side lengths here because it's going to be important for finding the area of this triangle. Okay, so here we go. All right. All right, so we can divide CD in half such that it's 1. And so we can use the law of cosines to get that x squared is supposed to equal 2 squared times 2 minus 2 times 2 times 2 times cosine of 120. 2 squared times 2 is 8. 2 times 2 times 2 is 8 times cosine of 120. We know that cosine of 120 is the same thing as negative cosine of 60. Thus, we can rewrite this as 8 times cosine of 60 minus 8. Cosine of 60 is 1/2, so cosine of 120 would be negative 1/2. This gives us 8 plus 4, and 8 plus 4 is 12. So now we can begin to find the area of quadrant 2. So we have that this side length right here is 12. We have that this side length is 1. Pretty clear construction for the Pythagorean theorem, right? So we can write this as 1 squared plus h squared equals 12. Solving for this, we get that h equals the square root of 11. Okay, so now we have our areas, right? And square root of 11 times 2 over 2, which will be the area of quadrant 2, would be square root of 11. So we now have our two areas, and we can begin to solve or finish solving the problem. Okay, so we know one of our areas is 2 root 3 plus root 11. 2 root 3 simplifies to root 12 plus square root of 11. Root 12 is m, root 11 will be n, and then we can have 12 plus 11. This equals 23, and that gives us our answer, D. Thanks.